As we're talking about systems of linear equations, sometimes we are not given a possible solution and we need to solve for it. One way to solve for this is substitution. It's where we're going to literally substitute one equation in for the other. But you have to notice what happens. We have to isolate one variable for one equation first. Substitute it into the other equation, make sure you do that, and solve the resulting equation for one variable. Either method, we substitute the value that we found here back into the original equation. So let's look at an example of substitution. So we have these two equations, 2x minus 3y is equal to 10, 5x minus y is equal to a negative 2x. You can see their graph over here, and so we're going to be looking to see if we get the exact same thing. So when we talk about substitution, we want to use the equation that has a leading coefficient of 1 for either variable. So notice this one has a 2 as a coefficient for x and a 3 for a coefficient of y. If I use substitution for that equation, I'm going to end up with fractions, and I know how we all feel about fractions. So this one has a coefficient of 5 for x and a negative 1 for y. This negative 1 is going to be much easier to solve for. So whenever I'm looking at it, let's go ahead and write down 5x minus y is equal to a negative 26. Now there's a couple of different ways you can solve this, but I want to solve this for my y. I want to isolate my y. So the first thing I'm actually going to do is I'm going to subtract 5x from both sides. So on the left-hand side of the equation now, I have a negative y equals, and I'm usually going to put my x in front, so negative 5x minus 26. Remember, I cannot combine these because one has a variable, one does not. Then I'm going to take and I'm going to divide everything by a negative 1. So that leaves me with y is equal to 5x plus 26. So now I have y equals something. So I'm going to come over and in my other equation, 2x plus 3y is equal to 10. I'm going to plug in this whole thing in for the y value over here. So I'm going to have 5x plus 26. And then notice I'm going to put my equals 10, my 3, and my 2x. I have to distribute this 3 because it's 3 times the entire y. So I have to distribute this 3. So I get 15x plus, what do I get? 26 times 3 gives me 78. And don't forget to bring down your 2x in front. I'll combine my like terms. So I'm going to combine these two terms. And I'll get 17x plus 78 is equal to 10. Now I'm solving for x. So I'm going to subtract 78 from both sides, leaving me with a 17x equals a negative 68. Now I'm going to divide both sides by a 17, leaving me with x is equal to a negative 4. I now have negative 4, which if you notice, 1, 2, 3, 4, negative 4, yep, that's correct on my x-axis. So now I have to plug this in for the x over here. We are substituting several different things. So I'm going to end up with y is equal to 5 times my negative 4 plus my 26. So 5 times negative 4 gives me a negative 20 plus 26. So y is equal to 6. Excuse me. This indicates that negative 4, 6 is a solution, which is correct based on our graph as well. Okay, so this is the substitution method. We're literally taking one equation and plugging it in for a variable in the other equation. So try a couple with substitution, and then we will look at the other method.